Hi and welcome, my name is Joshua from TAG. In this video, I will provide us with the practical explanations to the previous video I shared on basic statistics in R. So let's move straight to our RStudio platform, which by now we are all familiar with, and the dataset we'll be using for this tutorial is the CHIC WTS dataset that is freely available in R, and we're using the question mark because we are interested in reading some information about this data. So this data was collected from an experiment conducted to measure and compare the effectiveness of various feed supplements on the growth rate of chickens. So to see the first 6 observations in the data, we are going to use the head function, and the argument we are supplying would just be the name of the data set. So when you run this, you could see that we have printed on the console the first 6 observations with the names of each of the variables that we have here. So in the last video, I talked about univariate and multivariate data. So now from the word uni, it means data that has like one component, and more than one component. So the example we'll be using for univariate data here would be the information provided only for the weight in this particular data set. So how do we assess the weight? You said CHIC WTS $weight. When you run this, you could see the information printed on the console again in the form of a vector. So to know the number of observations we have for weight alone, we use the function length and we put CHIC WTS because we're interested in the weight. We still index it again using the $weight, and when you run it, you could see that the total number that we have for weight alone is 71. So let's assume that this is the total number of the population, for weight alone. Now let's move again and let's have an example like I shared in the previous video as well about the multivariate data. So I'm going to say information for the first 1 to 5 rows for all the column. So when you run this, you could see the result having more than one component. Now let's move away from here and talk about the concept of parameter and statistics. And I remember in the last video I said when you are talking of population, you think parameter, and when you are talking of a sample, you think statistics. So we have an idea now of the total number of observations we have for weight alone. Now, to save ourselves the stress of having to say CHIC WTS $weight, let's create a new variable called DAT and then store the information belonging to weight into this variable. So anytime we want to see the weight information, we just need to press DAT, and you could see on the global environment that information about DAT is already created. So let's take, for instance, now that I take the mean of this particular data DAT. So when you run it, this information is what we refer to as parameter because we are doing this on the total population. So this is a parameter, and this mean by default is an arithmetic mean. So let's take, for instance, that we want to also have an idea of what the geometric mean will be. So we're going to create a function, and then we would use that in arriving at the answer for the geometric mean. But before we go, let's see how a typical geometric mean is being calculated. So I'm going to show us a picture about the formula for calculating geometric mean. So you could see n root, n in this case is the total number of observations, n root of the product of all individual observations that we have in the data set. So let's go back and create our function. Let's call this gmin, and then we say this is a function that takes every information we have in the data set, and what is it going to do? It's going to take the product of the data set raised to the power of 1 over the length of the data set. So let's go and run this line of code. Now on the global environment, now we have a function created. So I can scroll down and you could see on the global environment that this is a function that helps in calculating the geometric mean. So if I say gmin now, if I say gmin, so I can easily put that, which is our univariate data. When we run this, you could see that the result is 248.8392. So let's proceed again to understand how we can get the harmonic mean. We are also going to create a function, but let me show us an image that describes how this is being calculated. So you could see here it is n over 1 over the first observation plus 1 over this plus 1 over the second observation up to the last observation. And if we take our mind back to the concept of indices, this formula can be rewritten in another different form, which is 1 over n into 1 over the summation of individual, the reciprocal of them raised to the power of minus 1. And this is the formula I'm going to use to create the function for the harmonic mean. So I'm going to say h mean is a function that takes the data set, and now we use the curly bracket. I spaced this down, and it's going to be 1 divided by length of the data set, now multiplied by the sum of the reciprocals of each of these observations we have in the data set over the 1 over the data set, and then we take this raised to the power of -1. So when we run this entire thing, let's go ahead and run. So we have on the global environment again a function created for the harmonic mean. So to get the harmonic mean for the univariate data, that is only for the weight, we say h mean and then we put the DAT. When you run this, you could see now that we have the result printed on the console. Now don't forget that everything we are doing now, the result we are seeing on the console are referred to as parameter, because we are doing this on the entire population. So we are going to see, and you could see from here, like if we are going to range them in like increasing order, we could see that the smallest of them all is the harmonic mean, followed by the geometric mean, followed by the arithmetic mean. So let's take for instance now that we are dealing with statistics. So for statistics, that means we are taking a sample out of the total population, and then we are now performing some kind of analysis on them. Whatever result we have in that case will be referred to as statistics. But before we go, I just also remember that we can also perform the median by saying median DAT. So we could see that this is the middle observation, 258. So how do we arrive at this particular 258? Don't forget, like manually, if you are calculating the median, you have to arrange your data and then you look for the observations that we have in the middle. So let's take for instance that we sort our data here to, we say sort DAT. When you run this, check what we have, and we will see that this is the observation 258. It is staying at the middle, that is dividing them into 35 equal parts. From here down to this place, the first 35, and again here the next 35, which is 70, and then it stays in the middle position. So that is that about median. In this video, this same video, I'm still going to tell us how we can also calculate the mode. But let's move and talk about statistics. So if we're dealing with statistics, we're talking about sample. Now let's create a sample from this total population that we have for the weight. So I'm going to call this sample, and I'm going to use the function sample. So we are sampling. You could see R is very easy because it tells me the first thing I'm going to put here is the data. So I put the data DAT. How many observations do I want? You know, how many sample, total number of observations I want for my sample. So I said 20, and then do I want it with replacement or without replacement? And I can as well add the probability, but I will stop at the level of the argument for replacement. So do I want it with replacement? So I will say replacement false. I don't want it with replacement. That means if it takes the first sample, then we have 70 observations left for it to take the second sample. Like that, it keeps decreasing downward. So when I run this, I can easily check SAMP, and then you could see that we have the information about SAMP provided on the console. Now whatever you do now on SAMP gives us the statistics. So if I say the mean, like the arithmetic mean, and then I run this, I said SAMP, and I run this, we have 262. If I say the G mean of SAMP, if I run this, we have 246. Now if I say the harmonic mean, H mean of SAMP, we also have 230. You could see now that this relationship that tells us that the least of this Pythagorean mean would be the harmonic mean, followed by the geometric mean, followed by the arithmetic mean. So this is something that is also very important that we should put our mind to. So finally, I'm going to talk about how we can calculate the mode for the population and as well for the sample. So mode. So we're going to create a function and we're going to call it MD. It's a function that takes a data set, and then the first thing it does is we're going to create a variable inside the function that takes the unique observations that we have in the data set. Then having done this, we're now going to index these particular unique observations and say which of them, now we're only dealing with the unique observations now, which of them is maximum. Those that are maximum, tabulate them, and finally match them with the data set. So I say U D. So when I run this entire line of code, then if I use MD and I open the bracket, don't forget that the univariate data we store as that, which is the information only for the weight. When you run this, you have it. Now for the example of the sample, we created a variable and we call it sample. It only has 20 observations. So if you say the mode of the sample, and then you have 380. So this is how we can perform some basic statistics ranging from the mean, the median, and the mode. In the next video, I'm going to take us a step further again into some basic thing we can do in R. Thank you.